Lipid membranes are not static barriers. They actively consume energy constantly. Think of your cell boundary like a never-ending chemical waterfall, where maintaining flow itself is what keeps life going against nature's urge towards stillness. All that organized activity, the signaling and transport inside, demands constant entropy production just to exist locally away from equilibrium. It's not structure that drives the engine. It's this intrinsic process of continuous energy dissipation across those microscopic boundaries, governed by non-equilibrium thermodynamics.
What happens at those boundaries isn't just passive leakage, it is a constant negotiation of existence itself. Consider how cellular transport mechanisms actively pump substances against massive energy sinks, maintaining internal potentials that defy natural decay. This active maintenance relies on specific processes we saw earlier, the sustained consumption of gradients to keep the system perpetually driven away from stillness. It hints at something deeper about the nature of material organization, suggesting that life finds coherence not by settling down, but by relentlessly generating flux across its permeable limits.
But what happens when that constant energetic negotiation starts influencing structure itself? It is not just motion, there is patterned organization emerging from sheer flux. Imagine a swirling smoke plume creating momentary stable vortices. Those are cellular microdomains forming spontaneously inside the membrane fabric. These aren't random patches of oil. They represent complex informational substrates generated by gradients colliding at the boundary interface. Small shifts in how these molecules arrange dictate entire signaling events downstream. The very permeability acts as an antenna for cosmic patterns to manifest locally, driven purely by thermodynamic pressure differential. Which means something nobody expected for predicting cellular response. We must examine the geometry of flow itself next.
But that sheer flux, that ceaseless churning at the membrane interface, doesn't just signal, it organizes itself into something truly structured on its own terms. Think about a turbulent river system forming permanent whirlpools in different spots. That spontaneous self-patterning within lipid assemblies is what we observe here. These specific supramolecular formations aren't random clutter. They create distinct zones of function, like little informational islands dictated purely by how energy gradients collide locally. It suggests life achieves its complex choreography not through rigid blueprint adherence, but through continuous negotiation with physical forces alone. Yet some older models insist that these patterns require preset molecular instructions to even begin forming their boundaries. What dictates the geometry when nothing seems fixed?
What if the instruction manual itself is generated by pressure? Instead of needing a rigid sequence, think of a deep-sea vent where chemical gradients forge entirely new crystal structures in real time. That's this self-assembly at work. The membrane isn't just forming patterns, it's creating its own rules for organization through sheer energetic friction. This relates to how processes maintain internal states far from stability, which scientists call active transport mechanisms. It implies life is constantly inventing its local physics against the universe's slow slide toward uniformity. But when these emergent structures get big enough, they start interacting with other systems entirely differently, a change that redefines cellular communication itself.
It seems these self-generated domains are reaching a critical mass now. They aren't just organizing themselves, they are establishing true, localized sovereignty within the cellular environment itself. Think of a complex dam system that doesn't need an engineer up front. The physics dictates where and how it forms stable control points purely through flow resistance. This is where we move past simple structure into what I call intrinsic flow divinity. These aren't just random clusters, they are active pathways driven by the relentless energy drain required to keep things coherent at all. The old notion of a passive container simply cannot hold this reality.
We found that these organized pathways are far from independent islands of activity. They begin interacting with neighboring structures in a complex, wave-like choreography. Picture how sound travels through thick syrup. The energy shifts aren't just contained inside one boundary anymore. they ripple outwards across the entire membrane field. This pervasive interaction gives rise to what we term boundary permeability, or veiling. It's this capacity for constant interface negotiation that fundamentally shapes cell communication itself, proving existence is a shared process of dissipation. The full research archive is at jmthomasofficial.com.
The final realization is that these emergent zones are not just reacting to gradients, they themselves create informational rules governing how other structures behave. Imagine a complex magnetic field where localized flux generates its own polarity lines, dictating movement everywhere nearby. That's the essence of self-organization within these membrane rafts. It suggests life doesn't merely follow physical laws, but participates in generating them locally through sheer energetic friction. This capacity for local rule invention is what we call self-organization or cosmic patterning at this boundary. Think about how ripples propagate across a pond. Every single disturbance creates its own new waveform, forever changing the shared state of the surface itself. The true takeaway isn't understanding any one pump or domain, but recognizing that life's coherence relies entirely on sustaining those ceaseless internal disagreements with entropy. The full research archive is at jmthomasofficial.com.